calculate the standard heat of formation in kilojoules per moles for dinitrogen pentoxide from the following data. We have a few chemical reactions that we know the delta H, standard delta H value, and we're trying to find the standard heat of formation for N2O5. And there's a couple of different ways to do this calculation. One of them is using the Hess law, and in that one you need to write the standard formation equation of N2O5, which would be N2 plus 5/2 of oxygen producing N2O5 gas. And then using this as the target equation, using the three known equations, try to find all the components of the target equation from the known equations, manipulate them, and eventually putting things together. Now here we're going to try to use a different method. If we observe the three equations, now the only one that has something to do with N2O5 apparently is equation number 2. This one has N2O5 in it. And if we look at the other two equations, there's something about them. This, equation number 3 here, this is the formation equation, if you notice, of nitric acid. So this delta H here is actually the standard heat of formation of HNO3. And the first equation here is not a standard heat of formation equation because you're making 2 moles of water. But if you divide by 2, this would be the standard formation equation of water. And of course, delta H need to be divided by 2, which is going to give you negative 285.8 kilojoules per mole. And that is the delta HF standard for water. So we have a reaction delta H, and we have a couple of standard heat formations. And we know for that reaction, equation number 2, the delta H of reactions really should equal to the total of delta HF of all products minus the total of delta H formation of reactants. And if we look at the reactants and products, that really means 2 delta HF of nitric acid minus delta HF of N2O5 plus delta HF of water. And if we look at this equation, we know that, we know this, and we know this. We want this. Oh, this is a simple rearrangement. Okay, let's rearrange. Delta HF standard of N2O5 should equal to 2 times delta HF of nitric acid, which we already know, minus delta H of the reaction number 2 minus delta HF of the water. Put the numbers in. This is 2 times negative 174.1 kilojoules per mole minus 73.7 kilojoules per mole minus we already calculated here, so that's negative 285.8 kilojoules per mole. And the final result. Positive 11.3 kilojoules per mole for standard heat of formation of N2O5. If you use the Hess law method with the formation equation of N2O5 and using the Hess law to manipulate the reactions, the known equations and their delta H values, you would be getting the exact same result if you're doing it right.